Okay, Kelly, tell us about this awesome looking circuit that's on your bench and the Birdsong circuit. I I think it's super cool. I have a few questions about different parts of it too here. So, but I would love for you to
Yeah,
kind of like do the overview first.
yeah. Actually, this one is going to be. I have a couple of them sitting here. This one's easier to plug in because this one's got a wonky connector. But I'll let you hear it first because I think that's the easiest way to introduce it.
Yeah.
So
That is super
right,
cool.
so I just turned the sound off for a minute. So
Mhm.
the sound that you were just hearing is being dynamically generated by the analog electronic circuit. And right now, the bird thinks it's singing. I've just disabled the switch to the audio, the speaker line.
Mhm.
But what I'll do next is start to twist some of the knobs, which are the base resistors of the astable multivibrators. And you can
Yeah.
hear how the oscillating circuit and therefore the bird song changes with that. But I just wanted to play it for a minute
Yeah.
without touching anything so you could see that like the circuit makes remarkably complex sounds with only 5 astable multivibrators and a modified Hartley oscillator.
Yeah.
That
Yeah.
combination.
It was remarkably natural sounding in complexity. Yeah.
Right. And the pauses in between
Yeah.
and everything. So you see how by changing
Yeah.
the bass, it changes the song pattern. So you get different syntax.
That is
Yeah.
really interesting.
Yeah. Thank you. And
No, that is very, very cool. So that's actually a perfect lead in for some of my questions here, which is I think that the most interesting part of this entire schematic. So I'll show you this. I'm gonna zoom in so that people can see it in a little more detail, hopefully. Maybe not so blurry detail. There we go. Okay, so the schematic is mostly these little sections,
that's
which are
right.
the, yep, and those are the astable multivibrators.
Yep.
And they basically work by alternating off and on these transistors. And that is controlled by like a little charge pump capacitor circuit. So, once one of the capacitors is relatively charged, then it opens up the base on this transistor, which, opens the path from the emitter to collector. And then, so then you have like this side of the circuit that's on, but then as soon as that happened, because they have this cross-coupled feedback, then what happens is this side of the circuit starts charging, and then as soon as it gets above the base voltage, it turns on and the other one turns off, and so you keep getting this back and forth. And
Exactly. They're pulling each other. That's
yeah,
right.
and then all of the characteristics like the frequency and things like that can be adjusted by the different components in the circuit. Yeah. And so let's see, you have 5 of these, and they're set up a little bit different. They have different capacitor values. So like this one has 220 microfarad caps, this one has 100 microfarad caps. And of course, you can change the resistors here. Those are these guys are the potentiometers, the knobs. And then got 47 microfarad caps and 1 microfarad here. And then
47 twice in the circuit, which is, so I have since made some changes to the circuit
Mhm.
to try and get as much diversity of sound out of it as I possibly can.
Mhm.
Um, but the Blue Jay that you just heard is
Yeah.
exactly that circuit that you have.
Cool.
Point being that this particular model has a lot of options for modification and expansion, the addition of more oscillators that are coupled, right, to make
Mhm.
even more complex sound patterns. Essentially, the circuit can be thought of as 5 astable multivibrators whose purpose is to create syntax, meaning
Yeah.
a grammar. It's an
Mhm.
architecture, of a pattern architecture, so to speak, for one modified Hartley oscillator, which comes from the classic electronic canary birdsong circuit you can find
Mhm.
widely on the internet. By capacitively coupling the 5 sort of syntax oscillators, if you will, to the one voice oscillator, right, that's where the connections are coming in. And you can see that I've got the capacitors there, which then if you go up on the schematic, go up, there's, oh, not too far. There we go.
There we go.
So, so that's the point at which those 5 oscillators are connecting to the base of the transistor that's controlling the chirp of the audio transformer. So that's the voice mechanism of the bird, so to speak, like where, you know, the quality of the bird's sound comes from. And in that part of the circuit, if you make modifications to those capacitor values, you can make the voice either higher or lower pitched.
Mhm.
The values that I chose are just, I think, the most kind of generically bird sound like. But yeah, I mean, that's it. It's really simple. It's just 5 oscillators controlling one oscillator, where the 5 are for pattern and the 1 is for the
Mhm.
voice generation.
I
And I
I'm
keep,
curious about this mixing section.
oh yeah, okay.
Yeah,
And
talk about that.
yeah, that's another area where there were literally so many different ways I could have designed the coupling that I just sort of picked one that I was like, okay, well,
Yeah.
this one is cool, but there were so many other cool ones too. Um,
Why
I
did
mean,
you
I'm
pick
not
this particular one?
because I liked it,
What did you like about it, though?
but, but I mean, it's really that's it because that's
Yeah.
how. Let me move this guy out of the way, and I'll show you my breadboard here for a sec. I don't really spend a lot of time planning my circuits. That doesn't mean I don't do research. I do. Like, I'll have a concept and then I'll go scour around on the internet to see what existing schematics I can find that I can modify.
Mhm.
The electronic canary being one of them. But if you build that electronic canary circuit like as it is on the web, it
Mhm.
just goes chirp, chirp, chirp,
Sure.
chirp, chirp, chirp,
Yep.
chirp, chirp, chirp. It's like cool but annoying.
Which is sometimes what you're going for, but sometimes not.
So I wanted to, yeah, give it, like I said, more syntax to make it more like real bird song like. But yeah, the
Nice.
once I got the basic architecture of the circuit in place, like the
Mhm.
concept that there are 5 oscillators that make
Yep.
the syntax and one that makes the voice,
Mhm.
then like how I coupled them and so forth, like those component values, the capacitor values, or a diode or not a diode, or put the diode somewhere else, or swap out the wires. I'm going to show you
Mhm.
that here in a second so you get a
Yeah.
sense of what I mean. I mean, there's a lot of potential for expansion in the circuit. So, and I'm working on those right now. I'm working on a product that I
Mhm.
can sell so people can have one of these
Yeah.
and play with it.
Yes.
I'm also in conversation with researchers who study bird neurology, right, and bird song
Cool.
to look at ways that this circuit may support research and to understand. Because I really think
That's cool.
it's an interesting model for essentially how a bird's brain works to right to generate bird song.